All right, so we are talking today about the properties of real numbers. All right, so first off, we have some of the properties is going to be specifically for addition, and some of them for multiplication. Okay, and the properties are associative, so associative property of addition and associative property of multiplication. So associative, the word in this, the word that's in associative is associate, right? It's about who you associate. So if we talk about addition, now with addition, it just means that we can associate the different numbers, but yet the results are gonna still be the same. So for example, if I did A plus B first and then add the C, it's going to be the same if I decided, because it's easier to add them, is to wait for the A and just add the B and C first, then add the A, okay? So notice how the first parentheses, I'm associating A with the B, while the right side, the B is now associated with the C and not anything else. So it's just different associations, okay? So let's move this right to the center. Okay, so how about multiplication? Associative property of multiplication just says same thing, except it's multiplying. So let's say I multiply A and B first, then multiply by the C. But I could also multiply the B and C first, then multiply the A. Okay, so either way is fine, it's not a big deal. These will give you equivalent expressions so that you are good there. So the next property is called commutative. Having issues writing today. Commutative. Okay, so the main word in there is commute. Okay, commutative, meaning to travel, right? If you're commuting from one place to another, you're traveling. So if I had something like A plus B plus C, okay? If I was to do commutative, I can say it's A plus C plus B. So notice either the B commuted to the end or the C commuted forward. Either way is still commutative, okay? Now, another way to look at it, let's say I use the commutative property, but it kind of looks like the associative property, okay? So I could even say this, A plus B plus C, but if I was to do the commutative property here, it would be this, okay? This commuted, and notice that it's not an associative property because the A is still associated with the B, no matter if it's the left side or the right side, it's still the same association. So I'm not changing associations whatsoever. So therefore, that's only a commutative property where the C commuted from the back side to the front side, okay? All right, so multiplication, commutative property of multiplication. So if I had A times B times C, I could say that this is B times A times C, okay? So the A moves. But if I use a commutative property that looks like associative property, it would be like A times B times C. Well, that would be the same as C times A times B, okay? But I'm just doing the AB first. So notice that this would be still considered commutative property and not the associative property, okay? So please be careful of that. And the last thing here, well, there's one more after this, but it's kind of a combination of addition and multiplication. The last one that I want to talk about over here is identity. Okay, so identity property of addition means, so if I give you any number, like let's say 3, adding what to 3 will give me an identical result, meaning, so I'm gonna put this in red so it's not, it's just an example. So I take A, what do I add that to get A again? So in other words, what do I take A, what do I add to A so I then get A back again? Identical result. And the answer is 0. A plus 0 will give me A. So the 0 is the identity property of addition. Similarly, with multiplication, A times what will give me A back again. So your answer is going to be 1. A times 1 is A. Okay? And now the last property that we want to talk about is distributive. Okay, now you guys have learned about that a little bit, where you would distribute. So if I had A times B plus C, okay, so notice how I didn't put it in this table because there's addition and multiplication in here. And you're like, well, typically we would add the B and C together and then multiply the A. You're right. But what if these were algebraic expressions, right? It could be like, let's say 2 times x plus 5, right? I can't add the x and 5 together, so therefore I'm kind of stuck, so that's where we use the distributive property, okay? So the top one would say A times B plus A times C. So think of it as, think of it as the A is the handout that I bring to class. When I distribute it to all of my class, so think of the B plus C as the students in the class, okay? So when I distribute the A, everybody will now have a handout, right? So that's the way you want to think about it. So that's what the distributive property would be. Oops. Okay. So in this case, it would be 2x plus 10. Okay, because 2 times x is just 2x. 2 times 5 would be 10. All right, so that's the distributive property. Okay. What else do I want you to know? Okay, so if I was to give you examples, it would be something like this. Let's say, again, I'm going to do an example with fractions in it, because that's what you guys love so much. Negative 6 over 7 times x minus y plus 21, okay? So again, if you look inside the parentheses, I can't add anything together. X is not the same as y, which I don't know what those numbers are, so I can't add it to 21. So this is where I would distribute. So I would do this times this, which gives me a negative 6 over 7x. Let's change this back to green again. Then I got this times this, which gives me, again, spawn. If we look at spawn, they're both negative, so it's going to be a positive 6 over 7y. And then this right here. So now I got, again, spawn, so it's going to be negative. And the 21. So you're like, well, what do I do with the 21? The 21 is not a fraction. If it was a fraction, I'd do top times top, bottom times bottom, right? Well, think of it this way. You're actually doing 21 over 1. I can write anything as a fraction. So this right here, I'm going to write it out first. So I essentially, how do I want to do this? Let's do it this way. 6 over 7 times 21 over 1. And I want to box this because this is what we got to figure out. Okay. Okay. So that's what I got to figure out. So again, I look at this, right? This, anything going 6 and 7, and your answer is no. How about 6 and 1? Definitely not. Okay. So I look at 21 and 1. Nope. How about 21 and 7? Yes, there is something that goes into those two. What does? 7 does. 7 goes into 7 one time. 7 goes into 21 3 times. Okay. Awesome. So look at the bottom. The bottom is going to be 1 times 1, which is just 1. And the top is going to be negative 6 times a positive 3. Spawn. And they're opposite signs, so therefore the result is going to be negative. So my answer is going to be negative 6 over 7x plus 6 over 7y minus, because they're opposite signs, negative, and then it's going to be 18. Now I do not, like, you might want to do this, but that is no longer necessary because 18 divided by 1 is just going to be 18. So that means this would be my final answer. Okay? And then the last thing is about like terms. Okay? So this is where you add and subtract what we call polynomials. Okay? In other words, if there was more than one term, what do we do? And what can we add? What can't we add? Because I'm sure that when you're up here, you're like, well, how do I add x and 5? And how do I know that I can't add x and 5, right? So that's what we're going to talk about right here. Okay? So before I do that, I'm going to do this. And you're going to be really confused really quick, and then you'll find your way again. Actually, let's undo that. Let's do this in a Okay, so this is a term, right? So there is names to this. The green here is called a coefficient. The red here is called the base. And the blue here is called the power or the exponent. Okay, so the 3 is the only one that has two names to it. They're special, but the x is the base and the coefficient. Okay, so in order for it to be like terms, okay, what has to happen is that the base and the power has to be the same. I'll say are the same. In order for it to be like terms, in order for them to add together. Okay? So, for example, if I have 19x minus 10 minus 17x plus 45, okay? Now, the other part I want to tell you is this. We often wonder if, let's say, for example, the 10, is that a positive 10 or a negative 10? Is that 17x a positive or negative? Is that 45 a positive or negative? Is that 19x a positive or negative? Okay? So I'm going to tell you to take the sign in front of the number as a value of that, that term, okay? So for example, I'll try to do it this way. So the 19x is a positive because there's no sign in front of it, so it is positive. Think of it as a negative 10. Think of it as a negative 17x. And think of it as a positive 45. So think of it in that way. So now you know the 19 is positive, the 10 is actually a negative 10, the 17x is actually a negative 17x, and the 45 is positive, okay? In terms of like term-wise, if you look at 19x and the 17x, they are both the same base, right? Same base. And the power, since there's no power written there, it assumes it to be 1, so that means the power is the same as well. So those two are like terms right there. Okay, and then the negative 10 and the 45 are also like terms. So negative 10 is just a number, no variables attached to it. 45, same thing, just a number, no variable attached to it. So those two are like terms. Okay, so that's what we would want to do. We would want to add these two together. Use that. We want to add these two together, which is going to be 2x. And then we want to add these two together, which is going to give you a plus 35. So there is my answer. Okay, so that's how we deal with like terms. All right, so the phrase that they're gonna use is collect like terms. It just means put them together and add them. Okay, so if these bases, like these two bases here, are both x's, so that's why they're like. If one was x, one was y, then we couldn't add those two together. If one was r, one was s, I couldn't add them together. Unless they're both r's or they're both s's, then I could add them together. Okay? If you have any questions, let me know.